Hello friends, welcome to my channel. In this video, I will cover ISRO Technical Assistant 2015 paper. This is part 2. Question is brass contents. Brass is a alloy of copper and zinc. So copper 70% and 30% zinc. A is your answer. High speed steel. HSS belongs to category of high speed steel. It's tungsten plus chromium plus vanadium plus iron. Iron is majority 18% 4 18 4 1. Rest is Fe. So it's a alloy steel, alloy of iron, and major alloying element is tungsten, then chromium. Sometimes they are giving other alloying elements also. This is from Morse hardness test. The hardness number 1 Morse scale is assigned to its torque. Surveying tapes are made of material having low coefficient of expansion and enough strength. The alloy used is this same type question also they asked in IS. Invar answer is Invar. Percentage is 64 by 36. It's a nickel alloy. Iron 64, nickel is 36. A fluid is said to be ideal if you remember the graph, shear stress versus strain rate. Or velocity gradient dV by dy or strain rate you will get here. This is for ideal fluid. And ideal fluid, it's having zero viscosity. This area, entire area, you will get zero viscosity. We know tau equal to mu du by dy. Tau is 0. So mu also 0. B is your answer. An object of having 10 kg mass weighs 5 kg on a planet. The value of G at this planet is how much? So mass is 10 kg. W is m into G. So G value we have to calculate. G equal to here 5 kg. So 5 into 9.81 divided by your mass is 10. So if you solve this one, you will get 9.81 into 5, you will get 49.05, 4.9 meter per second square. B is your answer. 15. And question is, for a body floating in water, resultant pressure exerted by water act at. Body is floating in water. So if a body is like this, it's floating in water. Here buoyancy force, resultant force exerted by water act at. So force of buoyancy, it will act here. CG of the submerged portion. This area is submerged portion. So its centroid portion is here. So not the whole body, it's only the centroid of the portion body on water. And FB is formula also very important. Volume of fluid displaced into rho g of this liquid, surrounded liquid, rho g of liquid. VFD is volume of fluid displaced, this volume only. Question is, if mercury in a barometer is replaced by water, the height of 2 centimeter of mercury will be following dash centimeter of water. We know pressure is same, but pressure formula is rho g of fluid into height of fluid. Height in hg term given, so it's, if you convert it in water term, it's height of water. So G same cancel. Rho fluid or Hg, here fluid is Hg, height of Hg column, rho of water into height of water column or height of water. We have to calculate H water. So given is density. For density of Hg, it's 13.6 into 10 to the power 3 into height is 20 centimeter. Here also water in centimeter, so no need to change it. Divided by density of water, it's 1000 kg per meter cube. Then 13.6 into 2, you will get 27.2 centimeter. A is your answer. You just remember this one, then put the values, you will get your answer. P equal to rho GH. This question also based on same formula as discussed in previous question. A pressure of 25 meter head of water is equal to how much? We know same formula, P equal to rho GH. Here H is in water head, it's given rho G of water. Pressure value we have to calculate. Water it's 1000, it's in kilonewton. So then 9.81, you take it 10. Then height of water it's 25, then it's in kilonewton, so divided by 10 to the power 3, 10 to the power 3 cancel. It's 250 kilonewton per meter square. This is approximately because we took G as 10. So its answer is 245 kilonewton per meter square. B is your answer. In this question, an odd-shaped body weighing 7.5 kg occupying 0.01 meter cube volume will be completely submerged in a fluid having specific gravity of fluid we have to calculate. S value we have to calculate. So our force of buoyancy is upwards Fb, then downward. Weight of the body, weight is given, so you have to calculate S value for the fluid. So W equal to, for this body, its weight equal to its volume into its specific weight or rho g. Volume into rho g of body. Then volume given, you can calculate rho into g. You have to calculate only specific gravity, so only you keep rho term. Here you have to multiply, unit will come in Newton, so rho equal to 7.5 into G divided by B. G also you can cancel, 7.5 divided by 0.01, leave it. Then force of buoyancy, we know force of buoyancy is volume of fluid displaced into rho g of fluid. It's completely submerged, so Fb equal to W. So you can write it as W. So W given So from here we can get rho value of fluid. So rho of fluid, it's equal to W is 7.5 into G divided by volume of fluid displaced. It's completely submerged, so equal to volume of the body, full body, into here G is here. So you have to calculate specific gravity, so this step is not required. This complete step, it's not required. You will get rho here, rho of fluid, G cancel, it's 7.5 divided by 0.01. So it's S value we have to calculate. S is density of fluid divided by density of standard fluid. So 7.5 divided by 0.01. Standard fluid is water, it's 10 to the power 3. If you solve this one, you will get 7.5, it's 75 by 100. 0.01, you can write 1 by 100 into 10 to the power 3. 100 cancel, 75 by it's by 10, 75 by 10. So here 75 by 100 you will get 0.75. D is your answer. Heat flows from one body to other body when they have, one is different heat content, no different specific heats, no different atomic structure, no different temperature. Yes, heat will flow if they are having different temperatures. D is your answer. Which of the following has maximum value of thermal conductivity? For aluminum, its unit also very important. Then steel 15 to 35 watt per meter Kelvin. Then for brass 120 watt per meter Kelvin. Copper, it's 385 watt per meter Kelvin. So higher is copper. D is your answer. If in option copper will not available, then you will go for aluminum. Question is, in the heat flow equation, Q equal to Ka T1 minus T2 divided by X torque, X by Ka is known as, it's one dimensional Fourier law of conduction, Fourier law of heat conduction. It's Q equal to minus K by dx, or K, sorry, it's small t that took, so T2 by X. The term X by K, or we can write it as T1 minus T2 divided by X by K, or we can write it as T1 minus T2 divided by thermal resistance. This entire term X by K, it's thermal resistance. So from option A is your answer. Thermal conductivity is K, heat transfer coefficient, convective heat transfer coefficient, it's H, then thermal resistance is X by K. A steam pipe is to be insulated by two insulating materials put over each other for best result. Steam is flowing inside, so you have to put insulation. So heat transfer should be minimum. So better insulation should be put over pipe and inferior one over it. Yes, A is your answer. In a centrifugal pump, when the impeller speed is doubled, so impeller speed is double, head develops becomes what? Let impeller speed, initially it's Initially it's n, second case it's 2n. Head developed we have to calculate H1 and H2 relation. And for pump we know power head and discharge Q. These relations are very important. It's n square, then nq. For diameter, its Q is proportional to dq. Your head is proportional to d square. Your d to the power 5. Power is proportional to d to the power 5. And here in this question, when impeller speed is doubled, head developed. So head and speed, this relation you have to consider. H is proportional to n square, or h1 by n1 square equal to h2 by n2 square. So h2 value we have to calculate. h2 is h1 into n2 by n1 whole square. h1 into n2 is double of n1, initial double 2n1 h2 value we have to calculate, divided by n1, its square, n1 cancel, 4h1. It's 4 times of initial head, so C is your answer. This is the end of this part. Friends, one thing I want to share, feedback is very important in making videos. At least you can comment, any suggestion also you can give. Thank you friends. Thank you for watching my video. Thank you.